Question 4 was a ratio question. It says Anna and Beth share some money in the ratio 2 to 5. Beth has £180 more than Anna. How much money does Anna have? I'm going to use bar modelling to answer this question. So the first thing I'm going to do is draw the ratio of money. So we've got the ratio of Anna to Beth is 2 to 5. So Anna has 2 parts of the ratio, Beth has 5. Up to this point here, both Anna and Beth have the same amount of money. We know that Beth has £180 more than Anna, so these 3 boxes here must be £180. So to find out how much one part of the ratio is worth, I'm going to share £180 into these 3 equal boxes. So I'm going to do £180 divided by 3, which is 60. So I know that each box is worth £60. So to find out how much Anna has, she's got 2 boxes, so I'm doing 2 lots of £60, which is 120. Question 5 was a probability question. It's about counters in a bag that 5 are yellow and the rest are red. It says Faye takes 2 counters at random, work out the probability that both counters are yellow. I'm going to draw a probability tree just to show how I'm getting these probabilities. So we're going to draw a tree, and this represents the counters that Faye takes out of the bag. So she can either take a red or a yellow. We know that 5 out of the 12 counters are yellow, so the probability of getting a yellow is 5 out of 12. The rest are red, so there must be 7 red counters on the first time she takes out a counter. So the probability of getting a red the first time is 7 out of 12. Now we're going to look at the probability of her taking out a red or a yellow on her second time. So if she takes out a yellow counter the first time, the second time there will be 1 less yellow counter in the bag. So there will only be 4 yellow counters out of a possible 11 because she's taken 1 out of the 12 counters away. The amount of red counters will stay the same because she hasn't taken a red counter out, but that's still out of 11. Now if she takes a red counter out first, the probability of getting a yellow counter, well, there would still be 5, but we would have it out of 11 because she's taken 1 red counter out. The probability of her getting a red counter the second time as well as the first time, well, she's taken 1 red counter out, so we'd have 6 left in the bag out of 11. So the probability that Faye takes out a red and a red, we're going to use our AND rule, so we're going to multiply our probabilities together. So the first time she gets a red, that's a probability of 7 over 12, and we're multiplying that by 6 over 11. Now, you don't actually need a calculator to do this. When we're multiplying fractions, we're multiplying the numerators together and the denominators together. 7 multiplied by 6 is 42. 12 multiplied by 11 is 132. You can leave your answer as a fraction, and this simplifies to 7 over 22. Our final question is a data question, and it's looking at finding the interquartile range of a list of discrete data. Now, our discrete data is currently not in ascending or descending order, it's all jumbled up. So we're going to put it in ascending order first. So we get 1, 1, 1, 2, 3, 3, 6, 6, 8, 8, 9, 10. So I've put my data in ascending order. In order to find my interquartile range, I need to find the upper quartile and subtract the lower quartile. So the lower quartile is the piece of data that is 1/4 along my list. The upper quartile is the piece of data 3/4 along my list. I've got 12 pieces of data here. So to find out my lower quartile, I'm going to do 12 plus 1 divided by 4, which is 13 divided by 4, which is 3.25. So this means I want to find the piece of data between 3 and 4, or the third and the fourth. So my third piece of data is the number 1 here. My fourth piece of data is the number 2 here. So my lower quartile is directly between those two numbers. So my lower quartile, I'm going to find the midpoint of 1 and 2. 1 plus 2 divided by 2, which is 3 divided by 2, or 1.5. Now my upper quartile, I'm going to do 12 plus 1 multiplied by 3 over 4 to find out which entry it is. So that's 39 over 4, which is 9.75. So I'm looking for the piece of data between the 9th and the 10th piece of data. So my 9th piece of data is here, and my 10th piece of data is there. So I'm looking for the piece of data directly in between those two. Now they are both exactly the same, so my upper quartile is 8. So my interquartile range, IQR, that is 8 subtract 1.5, which is 6.5.